So nanopore sequencing has become quite famous nowadays. ONT, or Oxford Nanopore Technologies, make these sequences. For example, the Promethean, they output data in form of a raw current signal, which is pretty big, 1 to 2 terabyte per sample. But that is necessary to do base calling, methylation calling, and many other cool analysis. Back then, ONT used to store this data in a file format called FAST5. We identified a lot of problems with FAST5 back then. It was not very high speed, and there were a lot of breaking changes done to the API, making the development very hard. We tried to communicate these problems to ONT publicly and privately. For example, we showed in like 2019 that how horrible this FAST5 bottleneck is, and then even showed that a simple ASCII text file format could do much better than the FAST5 format. And as a joke, ironically, we just called it slow5, thinking ONT will do something about it. Time passed, there weren't any improvements, and I included this chapter as the last chapter in my PhD thesis, and Hengley was one of the persons in the defense committee, and he asked, what about a binary format? And that encouraged us to develop this into a serious file format, amongst other reasons. And after like an year, we developed the core of slow5 and put the preprint out there. And then eventually, we got like huge performance gains and benefits. And finally, it got published in Nature Biotech. And since then, it has gone into a huge ecosystem comprising all these parts. I'll go quickly one by one. So, of course, a serious format should have a serious specification. So here it is. And then libraries, the heart of slow5 format is the C library. Inspired from softwares like Minimap, very limited dependencies here. You don't have to get crushed by all these huge snakes like Python, Mamba, Conda. Just call make, done. And of course, if you know how to pet the snake, slow5 is there. And for R people, there's R slow5, thanks ChatGPT. And some community developed tools too. And coming to tools, slow5 tools is the major tool for manipulating data, very bash friendly, as any bioinformatics tool should be. And we have Buttereel for base calling and methylation calling, and then Squigulator for simulating nanopore signals, and F5C for signal alignment, and slow5 curl for remote file access, and many, 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 many more, both from us and other community members. And also you have data sets, thanks to AWS, quite a few we have uploaded, and also some links to ENA, SRA uploaded slow5 data sets. And if you want to get started with development, a lot of resources are available. And then now back to the timeline, few months after we published slow5, here ONT says we are coming up with their own file format, which turned out to be something called POD5, which is the default file format in ONT sequences. There have been many breaking changes in POD5, so it's hard to benchmark, but just 1 week before I did a benchmark, and it's based on that. So the file sizes are very similar. Performance-wise, reading performance for sequential access, if you are a very rich lab with access to terabytes of SSD, similar performance. But if you rely on traditional hard drives, especially on NASA's and HPC file systems, slow5 seems to be still better. And then when come to random access performance, slow5 seems to be still a lot better. And then about the complexity, slow5, only 2 dependencies. One is zlib, the other one is optional, Z standard. And here is POD5 with arrow, boost, and all the things. After spending 1 hour, I just gave up drawing the tree. And then don't worry, we have BlueCrab for converting back and forth and to do real-time conversion as well. Anyway, slow5 future, currently we are using as the central format at Garvan Institute Sequencing Facility. We are now sequencing 1,000 Promethean genomes, Promethean samples per year, opposed to 100 few years ago. So it's all MIT license. No time for acknowledgement. You can read it. And if you missed anything, slides are here. Thank you.